The function was f of z is equal to z upon z bar. So what did I do? I just write it as x plus iy upon x minus iy. Then I put y equal to mx and try to see it depends on m. So I concluded that limit does not exist, correct? Because if limit exists, then I can go from any path. My limit value should be same, correct? This was in your semester 3, correct? Yeah. But I'll tell you one more trick. You don't have to do all the time that the whole thing जो भी किया अभी पहले. Remember one thing. If your function is completely in terms of z, that means uh, if f of z is, we will say completely in terms of z. In terms of z, that means what? No term of z bar or anything, or z into z bar or mod z, anything. You have to have only z term. Then what? Then the function f of z behaves like real valued function. Behaves like real valued function. That means what? If you are given something like this, f of z equal to z square plus z plus 1. Okay, so this function is completely in terms of z. Now to find limit z tending to 1, what will you do of this type of function? Yes, you just have to directly put the value of z, correct? You don't have to think anything. You don't have to put z equal to x plus iy and then substitute and then solve. You don't have to do anything here, because your function is in terms of z. It behaves like your real valued function. So in real valued function, how do we solve this type of question? We just directly substitute, that is 1 square plus 1 plus 1, that is equal to 3. Done. Similarly, let me take one more. F of z equal to z raised to 5 minus 1 upon z minus 1. Suppose this is your function and you are asked to find limit z tending to 1. Can you give me of f of z? What will be that? First question is, your function is in terms of z only. You should always ask one question. If the function is completely in terms of z, then the task is easy. Correct? Check. So it is definitely in terms of z. And how do you solve this type of limit? Anybody? Yes, anyone? How do you solve this type of limit? And let me go here. That is, you want to ask limit z tending to 1, z raised to 5 minus 1 upon z minus 1. As I told you, this works like a real valued function. So how do you do in real valued function? Oh, I think I should ask with someone. ऐसे तुम लोग नहीं बोलते. Yeah. Bhagyashree, can you hear me? What is the limit of this? How to do? Yes. Okay, anybody else? Uh, Shreyas? Okay, fine. How do you do that? Just tell the trick. Tell the technique. Okay, so you want to use this, huh? Limit extending to a, x raised to n minus a raised to n upon x minus a. What is the answer? And do you remember ये formula आया कैसे? Do you remember how this formula came into picture? अभी अभी मतलब अगर मैं ये क्वेश्चन एक 12th स्टैंडर्ड या 11th स्टैंडर्ड से पूछता देन आई एम एक्सपेक्टिंग दिस आंसर, बट नाउ I'm talking to a BSc third year BSc student, so I don't expect this answer to be yours. Do you remember ये फॉर्मूला आया कैसे? Limits you see, if you remember one rule then you don't have to remember any of the formula of limit. Only one rule works everywhere, mostly everywhere. There will be one or two limit where it does not, but it works everywhere. Anybody else? Okay, Pratiksha. Yes. Okay. uh, Anybody else जिनको पता हो कि मतलब ये फॉर्मूला मतलब I don't want to be in the formula. I just want a rule which can tell you the limit of this form. Now I have given you a hint. Limit of this form. Think about this. What is the form of this? If I say one more word, then 0 by 0, definitely. Yes. So since it is 0 by 0, so which form, which formula, which rule you use? हाँ, yes, that is Lapital rule बोलते हैं उसको. हॉस्पिटल जो rule. L'hôpital. H is silent. Perfect. हाँ, बट अभी बीएससी में नहीं बोलना चाहिए बिकॉज अभी करेक्ट प्रोनाउंसिएशन पता है तो. ठीक है. एच साइलेंट है. लॉपिटल रूल. या परफेक्ट. दिस इज व्हाट आई वांटेड फ्रॉम यू गाइस. करेक्ट. आई डोंट वांट दिस रूल. अगर मैं ये 11 12 को बताता वो तो यही बोलते कि सर एक फॉर्मूला है अपने पास ये वाला, विल अप्लाई दैट, हाँ ठीक है काम हो गया. बट नाउ हियर अपने को डेरिवेटिव्स भी देखना है ना. लापिटल रूल. सो व्हाट इज द आंसर? Derivative of the upper one, that is what is the L'Hopital rule? When you are having 0 by 0 form or infinity by infinity form, correct? What is the rule? You need to differentiate the numerator and denominator, correct? So once you differentiate, that is limit z tending to 1. If you differentiate this, then you will get 5 z raised to 4 upon differentiation of z, that is 1. Put z equal to 1. Now there is no issue, so answer is 5. Perfect. Very nice. Is that clear? Okay. Now I could do this only because the function was only in terms of z. Correct. So the first question to solve any limit, continuity, differentiability, and I told you behaves alike. That means what? All the thing. That means if I take derivative of this, then also I can take derivative as I was doing in my real cases. Correct. What is my f dash of z for this? Z square. It is same as x square. So answer will be 2z plus 1. Do you agree? And if you take another f double dash of z, then it will give you 2. Same thing, everything will be same. At the place of x you are just putting z. Okay, let me ask you one more question. Now it will seem easier to you. Okay, what is the value? What is the answer? Come on, quickly. What is the answer? Okay, Ketan, can you hear me? What is the answer for this limit? Hey, that is quite simple, yeah. You should answer this. Okay, Satish, answer limit z tending to -1, and this is your function. Okay, nobody. Is there anyone? Yes, Sreyash. Sreyash. Okay, so in the numerator it is linear term, denominator it is linear term, correct? Now it is z plus 1 and z tending to -1. So I don't have any option to cut z plus 1. So answer will be definitely infinity. Na? This is 1 by 0 form. 1 by 0, correct? You don't have to think that much here. Yeah, I'll just give one more example. You don't get scared with the z. It is working same as x since your function is in terms of only z. Then you don't have to worry. Okay, in the denominator it is z plus 1 and the question is z tending to infinity. Can you tell me the answer now? So Nali, can you hear me? Can you just help me with this? What is the answer? How will you do this? This is 2z. Perfect. Very nice. Infinity upon infinity form. So what will you do? By using Lapital rule, correct? What will you do? You'll just have to differentiate numerator and denominator, correct? Now consider I as a constant, okay? Now if you differentiate numerator, what will you get? It is 2z plus I. Derivative of 2z will be 2 and derivative of I is 0. So that's it. And in the denominator it will be 1 plus 0. So answer is 2. Correct. Yes, is that clear to you everyone? हाँ अरे मतलब वही हुआ ना, डिवाइड बाय z किया एंड मतलब वही हुआ. Both the thing are same, correct? Because 1 by z you will put as that thing as a 0, but here I want to focus on infinity by infinity function. That is L'Hopital rule. I am just focusing on L'Hopital rule so that you should understand the importance of that. Because अगर divide by z किया तो that is also if you take 11th standard का 5th और 6th exercise is like this कि कोई भी अगर z tending to infinity हो and 1 upon z raised to n where n is positive, so answer is 0. So you always just see कि हाँ इसका power, इसका highest power क्या है, इसका just you will divide the thing, correct? But you are doing the same thing actually. You are doing L'Hopital rule only, but उधर हम लोग L'Hopital बोलते नहीं है. So that one more you can take it as a one more type, that is check the if it is z tending to infinity, take the degree. Here it is z power and here is also z power, so divide whole side by z and you will use this thing, correct? Limit z tending to infinity 1 upon z raised to n, that is 0 if your n is greater than 0. Yes, That is same as n raised to p, or you can say this is z, huh? Please, I'm sorry, actually my z and 2 looks quite similar. Okay, uh, shall I give one more question? In this type of Lapital rule, you just try to understand कि अगर z by z फॉर्म में है तो ठीक है, नहीं तो नहीं तो यू हैव टू वेट, यू हैव टू स्टॉप देयर, बिकॉज अभी तक मैंने कोई रूल नहीं बताया. इफ इट इज हैविंग एनी अदर टर्म, करेक्ट, then you have to stop, like in the previous case. Here it was having z plus z bar, so I proved this as limit does not exist by using your original method जो भी था, correct. So this is what you can do. किधर गया ये? Yeah, here also do you see that I z bar by 2, I did not directly put the limit. I just told you that this I just make it in the form of x and y, and then I put it the limit, correct, by going to your sem 3 exercise. Yeah, and otherwise I made it in that form. That is, here it is z bar, so I want my limit to be z bar. So if my z tending to 1, so z bar tending to 1. Now it is working as a real valued function. Everything it is in terms of z bar, और यहाँ पे भी z bar पे limit है. So directly I could put it. And here also किधर गया वो? Hey, where is that where I prove that the limit does not exist of that function? I think z upon z or z bar upon z was the function. Yeah, this one, correct. Here also see, I did not directly put. I tried to prove that this limit does not exist, correct? So how do you start? If it did exist, so from every value, so if you have any doubt that whether it exists or not, then you have to put the value x plus iy and go back to your this type of coordinate function. If you can do that. Yes. Okay. So now I think we are in a state to define now the definition of continuity. What is continuity? Correct? Can you quickly define 12 standard definition? Now I just want, I don't want epsilon delta definition for now, just for some time. What is the definition for continuity? A function is continuous at a point z naught if if I go to 12 standard definition, what was that? There was, I think, three things. Limit z tending to z naught f of z must exist, correct, and f of z naught also exist, and one more condition, that is limit z tending to z naught f of z that is equal to f of z naught, correct. By combining all things, we just used to write this thing, but if I take a real number, then I'll write as limit left limit is equal to right limit is equal to f of z naught. So I'll just see this one. This one will help. Suppose I am assuming that limit exists, and if that limit is equal to f of z naught, then we say that function is continuous, correct. In previous cases, in the definition of limit, this value is something w naught, correct, that was not same as f of z naught. So that was the definition of limit. Here the definition of continuity is that w naught will be f of z naught, and every theorem will be same जो भी हम लोगों ने algebra किया है and everything, correct. Now let us write the definition. Can you tell me anyone? Definition, that means your BSc definition. For all epsilon positive, yes, there exist delta positive satisfying, what is the condition delta is satisfying? Mod of z minus z naught, that is less than delta, and one more bracket such that mod of f of z minus f of z naught, that is less than epsilon, bracket close जो भी है, correct. So this is same thing you can write in the different format. Mostly बर्टन में तुम लोग ने ये डेफिनेशन देखा होगा, एंड रियल एनालिसिस बाय एस कुमरेशन उसमें ये डेफिनेशन देखा होगा. Both are equivalent, and but this seems good to me. So for epsilon positive, there exists delta positive satisfying mod of z minus z naught is less than delta, implies what is the condition? F of z minus f of z naught, that is less than epsilon. So this is the definition, correct. Why this is nice one? Because if you try to negate this statement, then this will be quite useful. You just have to break the first thing, break the first bracket, and negate this one, break the thing, negate this one, something like this, negation of the function. So that will be nice. Yeah, so this is the definition of continuity of a function. That means, do you see, this is same as real में जो भी हम लोगों ने define किया था. The condition, one condition is there, that is here it is open ball, and here also it is open ball. That means give me any z naught के around, if you take any open ball, I should able to find f of z naught. That is also I could able to find a open ball. That's it. This is the definition of continuity. Okay, now there are so many proofs which are quite same as जो भी तुम लोग ने किया, तो I'm not going to that part. We'll do some extra जो भी whatever continuity, composition of continuous function is continuous, and so many things, right. I'll do one more thing. I'll do a theorem. If a function f of z is continuous and non-zero at a point z naught, then f of z is non-zero throughout some neighborhood of that. So this is my theorem, this is what I want to prove. Now first let us understand, do you understand the statement first? The statement is, if your function is continuous and non-zero at a point z naught, correct. Function should be continuous and at z naught it is non-zero, then function will be non-zero throughout some neighborhood. That means if I draw here, it is z naught, and you are saying function is continuous at this and it is non-zero, so I should able to find a neighborhood, correct, such that throughout this neighborhood your function should be non-zero, and after that it may be zero or not, I don't care. I just want a neighborhood such that in that neighborhood function is non-zero. That's it. Okay, so this is what I want to prove. So how should I start with? Since we are given something, what is given to us? Function is continuous and non-zero, so we'll be using same thing, correct. Shall we start? Since f of z is continuous at z equal to z naught, correct, and by using the definition, now I will use one trick here, correct. I'll choose something, choose uh, let epsilon is equal to f of z naught by 2, mod of f of z naught by 2. Suppose I am choosing this epsilon, but first thing, is this epsilon positive? I already told you f of z naught is non-zero, correct. In the condition it is given that function is non-zero at z naught. Right here.